Hi, good morning. This is Prem Kumar, Assistant Professor, Department of Computer Science. Today, I am going to tell about the 8-bit addition program in computer architecture and microprocessor. So, before we see the program concept, we'll discuss about the algorithm part. So, how the 8-bit addition is going to perform is, so we're going to read the two 8-bit numbers from the number location, that is 8030 and from 31. And after getting the value from the memory location 8031 and 8030, we will be moving that memory location content to accumulator and to the B register. After moving the data from the memory location to the B register and accumulator, we will be adding it that to content and store the result again in the accumulator. So after storing the result, we will be calculating that if there is any carry occurs, the carry is also being moved to the memory location, another memory location, and will be store the result in the memory location will be coming out of the RAM. That is what the algorithm says. First, we start the program by loading the input data into the memory location, that is 8030H. Moving that data to the A register from the memory location 8030. So, what are the data we have in the memory location 8030 that is being moved to the register A? And the next one is after moving the first data to the accumulator, we'll be going to read the second data from the memory location. That is what we will be incrementing the memory location as by 1, that is 8031. After moving the memory location, after incrementing the memory location 8031, we will be reading the data from that location and move it that data to the B register. And we will be initializing another register, that is C, for 00 to store the if in case any carry occurs. Okay, then after initializing this C register, we will be go for the addition operation, that is the next step, add the two register contents. After adding these two register content, we used to check if there is any carry occurs or not. If it is any carry, we will be incrementing the memory location and we will store the result separately. If there is no carry occurs, we will separately store the result in the next memory location by incrementing it. So that is what we have that in that next few steps. We'll directly move on to the program now. So before seeing the program, we'll see about the flowchart. That is, we'll start and we'll be getting the first value to the accumulator, that is A, and the second value to the B register. And we have initialized the memory value, that is 00 to the C register. The purpose of storing the 00 to the C register is for the carry process. And next step, what we have is that we're going to adding the process, that is accumulator equal to accumulator content plus B register. So after adding this, we will have the result in the accumulator. So we're going to check if there is any carry occurs or not. That is the results we're going to accumulate. Whatever the value we have in the accumulator, we will use to check if there is any carry bits are occurred or not. So if it is 0, the carry is 0, what we do is we'll simply store the memory location content, we'll store the accumulator content to the memory location. And we'll be incrementing the memory location by 1 to the next location to store the carry. If there is any carry occurs, what we used to do is we'll be incrementing the C register by 1, and that is being considered as a carry bit, and that is also be stored in the case of the another memory location. So that is the purpose we have here. So we'll be storing the result as well as the carry in the memory location. So after storing the memory location, after storing the result from to the memory location, we'll end the session. Okay, we'll see the program now. So we'll start the program from the memory location 8000, and we have the mnemonics as LXIH. What is the first line? LXIH is we are telling that load the data which is in the memory location HL. The low order bit of the 30 is stored in the L, and the high order bit of our address 8000 is stored in the H. So that is what the command we have given, that is HL equal to 8030. And it is a 3-bit instruction, so it has occupied 3 memory location. After that, we have the memory location 8000, 8000, 3. In that 8003, what we are doing is we will be moving the memory location data that is in that 8030 to the accumulator. That is the second line. So we have that is M moving the memory location content to the accumulator. So it is a 1 byte instruction. So it has occupied the memory location 8003. And the next one is the memory location 8004. We'll have the next instruction, that is INXH. Here we are incrementing the memory location from 8030 to 8031. And from there, what we are doing is we'll move to the next instruction. That instruction is stored in the address 8005. What are the instruction we have is move p comma m. The second data we have it in the memory location. That data is going to be moved from the memory location to the B register. So the command for that is we'll be moving the memory location content to the B register. So as of now, we have received two content. One is to the accumulator and another one is to the B register. So again we have and then next instruction we have it is 8006. It is a 1 byte instruction, so it is occupied only 1 byte. So we'll have the instruction that MVIC. MVIC is nothing but we are moving some data immediately to the C register. So what is the immediate data we are moving? That is C. 0 is immediate data that is moving it to the register C. This C register is used to store the carry results. And after getting all these values, the memory location 8008, why it has been moved from 8008 is it is a 2 byte instruction, so it has occupied 2 memory location. 8006 and 8007 is occupied for them 2 bytes address. And the next memory location what we have is 8008. There we have the instruction that is add B. This add B instruction, what it does do is, see the command. So the accumulator content plus the B register is being added and the result is again stored in the accumulator. After this instruction, what we used to check is, we used to check if there is any carry occurred or not. That is the instruction JNC. JNC is nothing but jump not carry. If there is no carry, what we'll do is, we will be telling that move to the memory location by labeling it. See this operand RES. So if there is no carry occurs, it will jump to this location, that is 8000D. So what we have here is we will be incrementing the memory location. And what was the next instruction after incrementing the memory location? Whatever the result we have in the accumulator, that has been moved to the memory location. And also again we will be incrementing the memory location in order to store the carry result. So whatever the carry we have now in the C register, that is being moved to the next memory location. This is the process of if there is no carry occurs. If in case any carry occurs, what will happen is we will be just incrementing the C register, because initially it was initialized as 00. If in case any carry occurs, we will be incrementing the C register by 1. So it indicates that it is a carry. So the other process is, as usual, the other processes will be incrementing the memory location and storing the accumulator content to the memory location, and we will be incrementing the memory location and we will store the carry result in the memory location. So this is the process this instruction is doing. We will see the manual calculation. What is the manual calculation here? It is, see, we have two set of input. One is without carry and other process is with carry. See, this 8030 is having a value of 09 and 8031 is having a value of 08. So what the output is, after adding these two value, we will be getting the result, that is 13. It has been stored in the memory location 8032. And when we add these two value, we don't have any carry. So the 00 is also being stored in the memory location 8033. The second part of the input is telling that the 8030 is having A1 and 8031 is having the value of B2. So when we add these two values, we will be getting the result as 53, and that is stored in the memory location 8032. And when we add these two values, we will have the carry. That carry is also stored in the memory location 8033. This is the general input and output of what we have it in the program. And this is the manual calculation. It has been represented like this. 0A can be represented like this 000. The representation of the number has been based on the 84214 port. So 09 can be represented in this way and 0A can be represented in this way. Sorry. When we add these two bits corresponding from the low order bits to the high order bit, we will be getting the result. So see, it was clear that we don't have any carry bit over here. So the sum is equal to 13. So this bit is going to be represented as 1, and this 4 bit is be represented as 3. So it has been represented as 1 3. The second part is telling about the same manner will be represented, that A1 can be represented as 1010, and 1 can be represented as 0001, and D2 can be represented as 1011, and 2 can be represented as 0010. So after adding these two values correspondingly from the low order bit to the high order bit, we will be getting the result as 53, and we will know that after adding these two values, we will get a result as 53, and carry is also be getting. So we show that carry as 01 out to the memory location 8033. Hope you all understand this. Thank you.